There are several types of touchscreens, including resistive, capacitive, surface acoustic wave, and infrared. These touchscreens detect touch inputs by measuring changes in pressure, electrical signals, light, and ultrasonic waves, respectively. Let's start with resistive touchscreens. These consist of two thin, flexible layers, one made of resistive material and one made of conductive material, separated by a thin gap. When you press the screen, the top layer, usually a flexible plastic, makes contact with the bottom layer, creating a circuit at the exact point of contact. The screen's controller calculates the X and Y coordinates of the touch based on the location of the circuit. Now moving on to the capacitive touchscreens, the most commonly used type today. These rely on the electrical conductivity of the human body. The screen has a glass layer coated with a conductive material like indium tin oxide. When your finger touches the screen, it disturbs the electrostatic field, causing a change in capacitance. Sensors detect this change and the system calculates the touch point. Next, we have infrared touchscreens, which operate in a completely different way. These use an invisible grid of infrared light beams emitted by LEDs on one side of the screen and detected by sensors on the opposite side. When you touch the screen, your finger blocks the light beams at specific points, and the system calculates the X and Y coordinates based on the interrupted beams. Finally, let's talk about surface acoustic wave touchscreens. These rely on ultrasonic sound waves that travel across the surface of the screen. When your finger touches the screen, it absorbs part of the sound wave energy at the point of contact. Sensors detect the changes in the sound wave, and the system calculates the touch location. Capacitive touchscreens dominate the market due to their accuracy and durability.